Now we're at section 3.4, applications of the derivatives in business and economics. So we talked about marginal analysis back in section 2.1. Remember, it's that change in cost. So we can have marginal cost, marginal revenue, marginal profit, where there is a 1 unit increase in the number of products produced or sold. It is still the derivative, okay? So let's say your marginal cost is still the first derivative of your cost function. So really it's all on how you interpret it. So the interpretation is just a little bit more specific with the marginal analysis. So let's do an example. In example A, it says a company has determined that the cost of producing X number of refrigerators can be modeled by that given cost function. It gave us a reasonable domain. They can make between 0 and 200 refrigerators. And they give us the price demand function there at P of X. So the first thing it asks is for us to determine the marginal profit function. Okay, so marginal tells us that we are eventually going to take the first derivative of the profit function. But then we have to recognize that they did not give us the profit function. So look almost at the end first. What are they asking you to find? And then work backwards. Before we can take the derivative of the profit, we must first find the profit. Okay, so we need the profit function. So let's think. We know that profit is revenue minus cost. Well, we have the cost function. Okay, it's up there, it was given, but we don't have the revenue. So let's think about what the revenue function is. Revenue function equals our price times our quantity. Well, in this case, our quantity is X, the number of refrigerators. So we can actually replace that Q there with the variable X. So then we go, all right, because our cost function, notice up here, has it in terms of X, not price, then we want our revenue function to also be in terms of X. Okay, because remember, we're going to combine like terms in order to get that profit function. So we need both of our input values to be in terms of X. Well, notice here, they gave us the price in terms of the quantity. So in order for my revenue function, in order for us to find that revenue function, we're going to take X, that's the quantity, times our price. But our price is the same thing as negative 0.3x plus 460. So we get a revenue function of a negative 0.3x squared plus 460x. So be sure that you follow that logic. You can't memorize every type of problem. You have to analyze it. What are they asking me for? What did they give me? What am I missing? Okay, so now that we have the revenue, we can't do our marginal yet. We still have to find the profit function. So again, profit is revenue minus cost. So I'm going to take my revenue function, negative 0.3x squared plus 460x, and I'm going to subtract my cost function, which is 2x squared plus 15x minus 1,500. Oops, that's supposed to be plus 1,500. We need to distribute that negative, okay? Distribute that negative there. So we get a negative 0.3x squared plus 460x minus 2x squared minus 15x plus 1,500. Make this minus 1,500. Now let's combine like terms. We haven't even found the marginal profit yet. Combining like terms, we get a negative 2.3x squared plus 445x plus 1,500. Okay, all of that is just the profit function. So I'm going to change colors here so we don't get too confused. Now we can determine the marginal profit function. Okay, so remember the first derivative of the profit is the marginal profit function at X. So taking that first derivative, we get a negative 4.6x plus 445. So notice there were a lot of other pieces that we had to find first. In part 2, it's now wanting us to evaluate and interpret the MP, the marginal profit, at 145. So let's do the marginal profit at 145. So we just plug that in. Negative 4.6 times 145 plus 445, and we get a negative 222. Here's, if you recall how the marginal profit cost revenue is a little bit different, you have to state the production level. At a production level of 145 refrigerators, that means, if we're already making 145 refrigerators, producing the 146, we'll just call it a fridge, decreases our profit by $222. And again, it's decreasing because it's negative, so we don't need to put the negative in the sentence. That decrease tells us that it was negative. Okay, now we're talking about optimization, and remember that's just a fancy word for maximize or minimize. So it says a deli estimated that it can sell 500 sandwiches per week if it sets the price at $2.50. However, its weekly sales will increase by 50 sandwiches for every 5-cent decrease in price. The company has weekly fixed costs of $525, and it costs 55 cents to make each sandwich. So assuming that they must make between 500 and 1,500 sandwiches every week, determine how many they must make and sell to maximize profit. So again, that is a whole lot to unpack, right? So I like to start at the end. So it's asking us to maximize profit. Profit is revenue minus cost. Okay, so I need to determine my revenue function based on that information and my cost function because they did not give us a profit function. Now, if we go one little sentence back, I like to work backwards. It says, assuming they must make between 500 and 1,500 sandwiches. So that's giving us just the reasonable domain. So let's say that X represents the number of sandwiches. Then we know that has to be between 500 and 1,500. Let's go back another sentence. It says, the company has weekly fixed costs, okay? Weekly fixed cost of $525, and it costs 55 cents to make each sandwich. That is giving us the cost function, and notice it's linear, okay? How can we tell? It has a fixed cost of $525, so that's like our B or y-intercept. And if it costs 55 cents for each sandwich, that means the cost is increasing by the same amount every time. 55 cents, 55 cents, 55 cents. So it has a constant slope. So we can write our cost function. I'll write it over here. Has the fixed cost of $525 plus it increases by 0.55 per X. In other words, 55 cents per sandwich. Now we have to deal with the revenue. So let's go back up here to all of this. A deli can sell 50 sandwiches per week at $2.50. Okay, so that actually gives us price and a quantity. So we got a quantity of 500 and a price of 250. Awesome. Okay, quantity and price. Actually, here they're using X as the quantity, so X and the price. That doesn't tell me enough though, right? That just gives me 1 point on my revenue. I can multiply those and find the revenue for just that price. It says, however, its weekly sales will increase by 50 sandwiches for every 5-cent decrease in price. That also tells us that it's linear. In other words, it is a constant increase in revenue, 50 sandwich by the price, 50 sandwiches by the price, as the price decreases consistently. It's not by a percentage or anything. So if we can find 2 points on the sandwiches per week per price, then we can come up with a revenue function. So let's take a look. If it's 500 sandwiches per week and the price is $2.50, and if it increases by 50 sandwiches, then that means we also have a point of 550 sandwiches at $2.45 for our price. So let's go ahead and find that linear equation in reference to price and quantity. We're going to take 250 minus 245. So that gives us a slope of a negative 0.001. And it doesn't matter which equation we use, the point slope or the slope intercept. I'm going to use the point slope this time, minus y1. So it doesn't matter which one we use. I'm going to use the first point. So our y value or our price value is $2.50 equals negative slope times x minus the 500. And again, I am using the y minus y1 equals the slope times x minus x1. You can also use the y equals mx plus b. You just have to find what that b is. So if we distribute and we solve, let's see, we would get y equals a negative 0.001x plus 0.5 plus 2.5. So we get y equals a negative 0.001x plus 3. Now again, the quote unquote y here, looking up here at our points, that is our price. So that means we have a price formula. So price is a function of our quantity sold, the number of sandwiches, is negative 0.001x plus 3. Again, we still don't have the revenue function. So in questions like this, don't get overwhelmed because there's extra pieces in between. You feel like, am I even headed in the right direction? Yes, trust yourself. What do you need to find that revenue equation? So we got an equation with price with respect to quantity X. We now need the revenue. I'll go ahead and do that one in blue. So revenue, remember, is price times the quantity. And we want it just in terms of X because our cost is in terms of X. So we're going to replace that P with this expression right there. So here's our quantity X. I am replacing that P with a negative 0.001x plus 3. So we get a revenue function of a negative 0.001x squared plus 3x. All right, so we have now got the revenue function. Now we got to come up with the profit function because this is what we're actually wanting to do, is maximize the profit. So remember, profit is revenue minus cost, okay? So we have the revenue function, negative 0.001x squared plus 3x, minus the cost function, which was 525 plus 0.55x. So we have a profit function. Notice I'm using a capital P instead of the little p. One means profit, one means price. Okay, so be sure that you make that very clear in your writing, otherwise you will confuse yourself. So that gives us a negative 0.001x squared plus 3x minus 525 minus 0.55x. Combining our like terms. Okay, so we found the profit function. Now we need to maximize it. So we can use that first derivative rule. So the first derivative of that profit, finding that rate of change, we get a negative 0.002x plus 2.45. And remember, to maximize it, we have to figure out where it equals 0. So if we set that equal to 0 and solve it, we would get x equals 1,225. Awesome. One more step, right? We are wanting to maximize profit. So remember, that maximum point can occur at a local max, or it can occur at the endpoints. So remember, up here, They told us they can make between 500 and 1,500 sandwiches. So we need to figure out what the profit is at all three of those points and see which one's higher. So let's find the endpoints. The profit at 500. I am using the profit equation, not the derivative, not the revenue. We want to know what the profit is, not the slope. So we're going to plug that in. So we will have negative 0.001 times 500 squared plus 2.45 times 500 minus 525. So our profit at 500 sandwiches is $450, okay? Not the highest. Now let's find the profit at the other endpoint, the 1,500. So again, you're going to plug it in just like we did above, but to save room, because at 1,500 is going to take a lot of room. At 1,500, if I did all my math right, that's going to give me 900. And then if I plug in the critical value that I found down here, where we think that local max would be, that's going to give us a profit of $975 and around 63 cents. So this one is the highest. That is the value that gives us the maximum point. We need to sell 1,225 sandwiches to maximize profit at $975.63. All right, so we have one more concept in this section. It's called elasticity. Now, if you have taken microeconomics, you may have already studied the concept of elasticity, but basically it measures the percent change in demand when there is a small percent increase in price. Now, one of the things to remember is when price goes up, demand goes down. Okay? When the price goes up, the demand goes down. When the price goes down, generally the demand goes up. That's not talking about antiques or those rare, items. This is just general products, okay? When the elasticity is greater than 1, then we say that the product is elastic at the price P. In other words, there's going to be a much larger change in the demand in a negative way for a small change in price. So we want to decrease the price. Elastic's bad, we want to decrease the price. When the elasticity is less than 1, then we say the product is inelastic. In other words, a 1% change in the price, increase in the price, you have less than a 1% change in the demand. So that's not a bad thing. We can increase the price and not lose as many, so we still get more revenue. So on this one, we want to increase price. Very rarely does this happen just, by accident, but when the elasticity equals 1, we say that the product is unit elastic at that price. Also means that the marginal revenue or that derivative of your revenue is 0. We like it when it is equal to 1. This means that the revenue is maximized. Depending on what we know about the product will depend on which elastic formula we used, which elasticity formula we use. So sometimes all we have are 2-point values. Like we knew when we sold it at this price, we sold this many. We also knew when we sold it at this price, we sold this many. So if you are given just those 2-point values, we have this formula where elasticity equals the absolute value of your second quantity minus your first quantity divided by your first quantity. Think of it like a percent change from your original divided by your second price minus your first price divided by your first price. One thing that you might want to write in here, just to kind of clarify, that is the new minus the old over the old divided by the new minus the old divided by the old, or original. You can say original instead of old if you want to. Sometimes the Q2 and the Q1 people get confused, but you're always comparing it to what price you started with. Now, this is called arc elasticity. Now, those huge lines are still absolute value. We're not looking at negative elasticity values. Now, if we are given a demand function, the formula for the elasticity is the price divided by quantity. Now, keep in mind that price will be given. Do we need to increase it or decrease it? Because everybody has at least a starting price, right? Times the derivative of the demand function with respect to P. And that is key there, that the demand function needs to be Q with respect to P. This is also called point elasticity. Now, how do we interpret these? Here's a couple of examples. So let's say the elasticity is 0.27 at P equals 4. Now, since the 0.27 is less than 1, then we say it is inelastic. In other words, it doesn't have that big of a change. So we can interpret it if the price increases 1%. In other words, from like $4 to $4.04. The quantity demanded will decrease by only 0.27%. Okay, so notice this elasticity is not the percentage in decimal form, it is the percent. So you don't have to move that decimal anywhere when interpreting the elasticity. In the second one, we have an E of 1.03 with a price of 200. Notice that 1.03 is larger than 1, so we call it elastic. In other words, it's changing more than the percent change in price. So if the price increases by 1%, in other words, from $200 to $202, the quantity demanded will decrease by 1.03%. We never want the demand to decrease in percentage more than the price. Okay, so let's do a couple of examples. Here we have a gardening shop, and it can sell 300 ground tillers when the unit price is 200. When the price is reduced to 180, they sell 360 tillers, and we want to determine the elasticity and interpret it. It doesn't matter which we put first. Let's say we're doing the price and then the quantity. Then we have for $200, we can sell 300 ground tillers, but then they change the price, they reduce it to $180 and 360 tillers, okay? So this would be our price 1 and then our price 2, and this would be our quantity 1 and our quantity 2. In other words, the original price and quantity and the new price and quantity. So that means we're going to use the arc elasticity formula since we only have points. Remember, it's a big absolute value. So we take the new quantity, 360 minus the old divided by the old. So we're finding that percent change quantity. Then divide that by the new price minus the old price divided by the old price. In other words, the percent change in price. And when you put all of that in, we get the number 2. So that means that this guy is elastic, right? Since 2 is greater than 1, he is elastic. The demand is changing too much. If we were to interpret this just as it is, so here's a couple things for the interpretation. Just the generic means for every 1% change in price, there is a 2% change in demand. That is generic, right? We want to interpret it in terms of the 2 points that they gave us. If the price decreases because it went down by, now notice that decrease from $200 to $80, it decreased $20. So that means it decreased 10%. Decreased by 10%, 200 to 180. Then the demand will increase. Now, again, remember, the price went down, so that means the demand will go up. You've got that relationship. Think of anything that you want to buy. If the price is going up, you're not going to buy as many. If the price is going down, ooh, the price has gone down, I'm going to buy a bunch, right? So then the demand will increase. Let's go back up here. For every 1% change in price, there's a 2% change in demand. So if it decreased by 10, that means the demand will increase by 20%. So depending on what they're asking you, as far as the interpretations go, that's what we're looking for there. Now notice one thing that might help you in some of those interpretations. If you reduced the change in the quantity in the top there, you actually get a 0.20. And if you reduced the bottom, you get 0.10. Well, remember, the top was the quantity and the bottom was your price. That even helps you with your interpretation here. You just have to look to go, which is which. This was a negative. So as the price decreased by 10%, the quantity went up by 20%. All right, for example D, it says a company sells socks for $15 a pair. So they are giving us a price that they want us to work with. And then they're giving us a demand function for the socks at Q equals 170,000 square root of 20 minus P. P is the price, Q is the demand. Notice in part 1, they just want us to determine the equation or the formula for the elasticity with a generic P. So we're not going to plug in the 15 yet. So we've got elasticity of P. Remember, the generic formula is P over Q times the derivative of the Q function with respect to P. Again, we're not plugging in 15 yet. They just want the generic P, but I do have Q in terms of P. So we can put in 170,000 square root of 20 minus P. And now we need to figure out what the derivative of the Q function is. Now, one of the things that I would do is write that square root as a exponent of 1/2, so you can use that power derivative and the chain rule there. So let's do that kind of out here. So Q prime, or derivative of Q with respect to P, multiply the front by 1/2, we get 85,000, subtract 1, and so we get a negative 1/2 exponent. And then the derivative of the inside is 0 and a negative 1, so we just get a negative 1. So that derivative, if we clean it up, we have a negative 85,000 divided by the square root of 20 minus P. So let's plug that guy in there. Negative 85,000 divided by the square root of 20 minus P. So a couple of things reduce here. We have the 85,000, which we could go in here twice. These two multiply each other. So that gives us the absolute value of, say, the opposite of P over 2 times 20 minus P, but it's an absolute value. So that negative is really kind of obsolete. So we can just write that as the absolute value of P over 40 minus 2P. So that's just the generic formula. Now they're wanting us to plug in that 15, that price that they gave us. E of 15, we can just use that guy, 15 over 40 minus 2 times 15. So that would give us 15 over 10, which would give us a 1.5. Now, that guy's greater than 1, so it is elastic. So that means prices should be lowered to increase revenue. But that's not really an interpretation of what all of that means. So we would say at $15 a pair, a 1% increase in price, and it wouldn't hurt to say, you know, we're going from $15 to $15.15, will decrease demand by 1.5%. Now, the last thing is, at what price is the revenue maximized? So remember, that's the unit elasticity. We want to set that E of P equal to 1. We're going to take that P of 40 minus 2P, and we're going to set it equal to 1. Multiply both sides by 40 minus 2P. We get P equals 40 minus 2P. Add the 2P to both sides. and we end up getting 1333. So we would say to maximize revenue, price should be 1333. So it's one thing to find the elasticity to say the prices should be lowered, but how much? Lowered by what? So that's it. See you guys later. Bye.